Welcome. Today's topic is HDLC. HDLC stands for High Level Data Link Control Protocol. It is a protocol in data link layer and it is bit oriented. It is published by ISO, International Standardization Organization. HDLC supports both half duplex and full duplex modes in point-to-point configurations. So it's a bit-oriented protocol and it implements the ARP, automatic repeat request mechanisms. The modes are unbalanced mode and balanced mode. Unbalanced mode is there is only one primary which can give command and more than one number of secondaries or one secondary which can give response to the primary. Symmetrical mode is one physical station having primary and secondary and another station having both same primary and secondary. There are two dedicated links, so both of them can give the command and the response also. Balanced mode, it's a combined primary and secondary in both sides and both can give command and response through one dedicated link alone. So the modes in HDLC are normal response mode, asynchronous balanced mode and asynchronous response mode ARM. So normal response mode refers to the standard primary-secondary relationship where primary gives the command and the secondary response alone. Asynchronous response mode ARM is the standard primary-secondary relationship. Secondary also can transmit the data without the permission from the primary if the channel is idle. And asynchronous balance mode, all stations are equal, only combined stations are used on both sides. Anyone can give a command or response. HDLC has three frames: information frame, supervisory frame and unnumbered frame. So it is like an envelope. Frame is like an envelope for the transmission of different types of messages. I-frame is to transport the user data and control information. F-frame to transport only the control information, and information carried by U-frame is intended for managing the link itself. The link related informations are transferred through the U-frames. So the frame type in I-frame, the frame format is like this. It has a flag, address, control and the information. The information can be either the user data or the control information. FCF, frame check sequence and flag. S-frame, the difference between I-frame and S-frame. S-frame does not have the information field, otherwise the frame format is the same. U-frame has information in that. Management data related to the link is there in the information field of U-frame. So each frame contains the following 6 fields: beginning, flag field, address, control field, information field, frame check sequence and ending flag field. So flag is 8-bit number with starting number 0 and end number 0. All other digits are 1. So 8-bit sequence with 0 and 6 ones and 1 0 is called flag. It indicates the start and end of the HDFC frame. Then it uses bit stuffing. So sender wants to transmit the bit sequence having more than 5 consecutive ones, means it should not be taken as flag. So after every 5 ones in the data, after every 5 ones a 0 is inserted, meaning it is the data. And the receiver side, that 0 is removed and the data is taken observed for. So this is to so that the receiver does not mistake the data for a flag. We have this bit stuffing and removal process. Next, address. Address can be either 1 byte or multiple bytes. So first bit is flag, last byte is flag, which is 1 and zeros, and last 1 in 8-bit field. Address can be either 1 byte address or multi-byte address. If it is a 1 byte address, the last bit is 1. If it is a multi-byte address, in every byte ending number is 0. Only after the last byte, the last bit is 1. So meaning whenever the 8th, 16th or the whatever the multiples of 8th bit is 1 alone, the address field is ending and the next control field starts. So till that it is the address field continuing. Then control field. So in I-frame we have N of S and N of R. The elements, sequence numbers of the frame sent and expected in the ARQs. And in S frame we have code and N of R. N of S is not there. U frame we have 2 plus 3 bits of code alone. So the control field may be 1 or 2 segments. It's used for flow management. So if the first bit is 0, the frame is an I frame. If the first bit is 1 and second bit is 0. For 1, 0, it is S frame, and both first and second bits are 1. 1, 1, it is a U frame. They also have pole and final. So N of S is the number of the frame being sent in the ARQ, the frame number being transmitted. N of R, the frame expected, and N of R is the acknowledgement field also. Acknowledgement and the expected frame number is there in N of R number. Then control fields has N of S and N of R in I frame. S frame has N of R alone, and U frame does not have N of S and N of R. It contains the bits for N of code. Pole and final. When the primary is transmitting the data, the pole bit is set. P bar F bit, pole is set. If it is 1, it means pole. If it is 0, it means final is set. So when it is 1, pole is set, meaning primary wants to transmit data to the secondary, and when secondary acknowledges, primary transmits the data. Final means this bit will be 0, meaning final is set. The frame is sent by secondary to primary, and the address field contains the address of the secondary. The S frame control bit, control field. The first number, if it is 10, it indicates it's a S frame. In code, we have here 2 bits, and here 3 bits are there. So these 3 bits are N of R, the next expected bit from ARQ. This code 2 bits. If it is 0, 0, it is receiver ready. If it is 0, 1, it is reject. If it is 1, 0, it is RNR, receiver not ready, and 1, 1, selective reject. So see what is all that. Receive ready. If the value is 0, 0, receive ready. So it acknowledges the receipt of a safe frame or group of frames, since cumulative acknowledgement is possible in the last 2 ARQs. Receiver not ready. If the receiver is not ready, so the sender has to stop sending the frame. Then RNR 101 is given. Reject. If the value of the code is 0, 1, reject frame in S frame. This is negative acknowledgement used in the go back in ARQ to inform the sender before the sender time expires itself that the frame is lost or damaged, so we transmit the frame. Selective reject ARQ. If the value of the code is 1 and 1, SREJ S frame, this negative acknowledgement in selective repeat ARQ. So HDLC is frame check sequence. It's a 2-byte or 4-byte CRC. It's HDLC's error detection field. Then use of P bar F, which we have seen already. Then U frames control field. It has 2 bits here and 3 bits here, total 5 bits of code. Unnumbered frames are used to exchange the session management and control information related to the link between the devices. So it has the management information here, the same FCS and flag. It's divided into 2-bit and 3-bit total. So 32 different core types of U frames are possible. So these are some of the example codes: SNRM, SNRME, and its responses. So 5-bit code and command and responses are given. So this is about the HDLC. Thank you.